prepared. So the arc length here, you got both the formulas for area and sector. Those are perfect. One of the things that maybe they don't emphasize in class is that the angles have to be in radian when you're doing this. They kind of say that, but I don't know if it's that clear. So your S equals R theta is 7, but your angle is 30, and then to convert it to radians, you multiply by pi over 180, which I think is what you're doing right here. So that looks good to me. So sign off on that. For the next one, the formula is correct, but you do have to make theta in radians. So you have to use this pi over 6 in here. So your area is 1/2 7 squared pi over 6. So you got, I mean, it doesn't work out great, but you got 49 pi, and then on the bottom you have 12. Now, one thing we are missing that I think your instructor would probably ding you on is units. The arc length is in centimeters. This is in centimeters squared. Okay, what would you like us to do next?
Can we move to number 3, please?
Sure. All right, number 3, find the values for the following right triangles shown below. So you need all 3 sides. Okay, it would be wrong. Here's B. It would be wrong to write 2 over C. Okay, because they actually want you to find C. Okay, so the way you find C is this is A and this is B, and A squared plus B squared equals C squared. So you have 2 squared plus 3 squared equals C squared, 4 plus equals C squared, 13 equals C squared, C equals the square root of 13. So now the answer is 2 over the square root of 13, but do you know if your instructor said like, hey, you need to rationalize everything? Did that come up in class?
No, I think she would just want us to keep it like that.
Okay. All right, so secant of B, you have to remember that that is 1 over cosine of B. And there are reciprocal. Do you know them all, the reciprocal ones?
Sorry, you just put out.
I apologize. I had that happen in my last lesson. So if it happens again, just let me know. I really don't understand why that's happening all of a sudden tonight. So the secant is one of the reciprocal relationships. It's 1 over cosine. And then cosecant is 1 over sine. And then the last one is cotangent. It's 1 over tangent. Have you seen those?
Yes.
Because that is coming up here. Okay. So secant is 1 over cosine. So you can literally just do cosine and then flip it. So cosine of B is the adjacent over the hypotenuse, which is the square root of 13. But you can just flip it. You can flip this bottom fraction, square root of 13 over 3. Okay, so for the next one, tangent of A, do you want to try that one on your own here?
Yeah.
Here's A. It's
Would it be 3/2?
Yes. So the next question 4, it looks like you've got this down, converting from radians or 2 radians or 2 degrees.
Mhm.
Everything here looks good. Would you like new examples? Would you like us to go through these? What?
I think I have these down pretty well. I think.
Yeah, everything's correct. It's completely correct here.
Yeah, perfect. We
Right,
could just
so
move on to number 6.
Yeah. Okay, so number 6. 6 is a calculator problem. Just get to where I can snip this in. Okay. So B is actually more direct over here. Do you have your calculator handy?
Yes, I do.
Okay. The main thing here is to make sure your mode is in degrees.
Mhm.
Radian, and it may not look right. So when I do this, I get about 34.33 degrees.
Yeah, I got the same thing.
Okay. Now, this one over here, it's not formatted well. It's actually, I think this is a little bit more clear. Is they're saying the cosine is this. So you undo cosine with cosine inverse, but you have to do it to both sides of the equation. So A is cosine inverse or arc cosine of that number there. So you have to be able to take that additional step to be able to get the final value. And I get 44.77 degrees.
Yeah, I got the same thing.
Great. Now to go 2 radians, you have to multiply by pi over 180, pi over 180. And that number is your answer is whatever it becomes, say the number radians. You don't use the degree symbol. Same thing down here. Degree symbol is only used for degrees. You just whatever that number is, radians. Is that okay? Is that clear?
Yes.
Okay. Can we move on to 7 now?
Yes.
Perfect. So I like your instructor's hint on this question. The hint says for maybe one of you had to lean a ladder against the side of a building, but at least there's some sort of some sort of realistic scenario here. So the 32-foot ladder is leaning against the side of a building. If the ladder makes an angle of this with the side of the building, so you have to decide, is that this one or is that this one down here? So for me, the building is here. So it's not this one. It must be this one. So this angle right here is 20 degrees and 43 minutes. And probably you saw this like in the first section, like degrees, minutes, seconds. The calculation here is it's 20 plus 43 over 60. So for some reason, I think during like nautical times when we traveled the world by boat, like this was this class. So that's the angle measured. It's this right here. So they want the distance down here. They want this x. So relative to this angle right here at the top, which is what you have, is x opposite or the adjacent? And is 32, well, 32 is the hypotenuse. So is x the opposite or the adjacent?
The opposite.
It's opposite. So which trig function uses the opposite and the hypotenuse?
Sine.
Sine. So the sine of this angle, 20 plus 43 over 60, equals opposite x over 32. Equation like this to solve for it. So to solve for x, you multiply both sides by 32. So you got 32 sine 20 plus 43 over 60. And you can enter all your calculator at one time. That would be the most efficient way to do it.
Mm-hmm.
I will do it as well. See what we get as a final answer.
I got 30.61.
So I got 11.3.
Oh, I did not change. I still have it in the radians. Okay, wait, let me try this.
Okay, yeah, no good. Yeah, your mode has to be in degrees. I actually had a student put a label on the top of her calculator, and it was, it was radian or degree, because it really messed in this part of the class.
Yeah. Okay, now I got 11.32.
Okay, now this one requires units. It's feet.
Mm-hmm.
Okay, another and maybe, but like math, you're not always dealing with real problems, but like 11 feet sounds reasonable.
Mm-hmm.
If it was 500 or if it was like 0.1 feet, that wouldn't be reasonable. Okay, is that good enough for that question?
Yeah.
Or can we move on to 9 or 8, I guess?
Yeah, we can move on to 8.
Okay. All right, so find the measure of triangles, one positive, negative. They're coterminal with minus 170. So for coterminal, you either add 360 degrees or you subtract 360 degrees. And that's because it's in degrees.
Mm-hmm.
And coterminal just means like you go around the circle or you go around the circle again.
Okay.
So minus 170 plus 360 is 190 degrees. And that's your one positive.
Mm-hmm.
And then you can subtract 360. That's just going the other direction. 530 degrees. And that's your one negative.
Okay.
Now I recall you telling me like, hey, this is probably what the exam will be like, just with different numbers. Because there's some examples here that where like this changes just a tiny bit, but if the number's roughly the same, you'll just do this again. You'll add 60 and subtract 360.
Okay.
All right, use the Pythagorean ID. Cosine theta plus y squared, sine squared y equals 1 to find the value of y. Okay. This is there's a lot here. You've probably been looking at your unit circle at some point in this class.
Mm-hmm.
So x value is cosine and the y value is sine.
Mm-hmm.
Do you remember seeing that at some point?
Yes.
So this is your cosine and this is your sine. So you're just going to plug these numbers in. 4 over 9 squared plus y squared equals 1. And then you're going to solve for y. So this is 16 over 1 plus y squared equals 1. Now I'm going to convert this to an improper fraction, or just to a fraction, because we're going to manipulate it in the next step here. So when you subtract 16 over 81 from both sides, you get y squared equals 65 over 81.
Mm-hmm.
And then you take the square root of both sides. But when you take a square root, it's plus or minus.
Okay.
So that's y equals plus or minus the square root of 65 over 81, which is plus or minus the square root of 65 over the square root of 81. So it's plus or minus the square root of 65 over 9.
Mm-hmm.
65 is only divisible by 5 and 13. So it ends up just being remaining like that. So they say, but if you go back and look at the question, it says, oh, but y has to be negative. So you choose the negative one here.
Oh, okay.
But that's not the final answer, because it wants you to find cosecant of theta. Cosecant of theta is 1 over the sine of theta. Sine of theta is the y value, or the second value. So it's 1 over negative square root of 65 over 9. Like if you go back to the original problems, it's 4/9 comma negative square root of 65 over 9. And that's where this, comes from. It's the second value here. These are the same. So then you flip this. So it's just negative 9 over square root of 65. Okay. Is that clear?
Yeah, it makes sense.
Okay. Number 10. All right, so find cosine theta and sine theta if tangent of theta equals 11 over 8 and theta is in quadrant 3. So there's what I call the reference bow tie. And if you've ever seen a bow tie, it looks like this. You seen that before? Someone wearing a bow tie?
Yeah.
Okay, that applies here. So there's 4 quadrants, 1, 2, 3, and 4. And in the reference bow tie in quadrant 3, the triangle looks like this. Actually, I'm gonna make it bigger. That's really not very big. Okay, so there's theta. And so theta is always the angle made with the x-axis. So they're telling you, though, that tangent of theta is 11 over 8. So tangent of theta is TOA, right? Opposite over adjacent. So the opposite of this angle must be 11, and the adjacent must be 8. But there's a big but here. If you were to go to this point down here and you went left and down, these are now negative 8 and negative 11, but they simplify to 11 over 8.
Mm-hmm.
So that's important. You have to get the sign right as well.
Okay.
And if you haven't figured that out yet in this part of the course, like there's a lot of steps that do basically lead, like if you don't do them, you're off by a negative, or it just could create a lot of problems. So just really be considerate of that.
Okay.
So now you got to find the hypotenuse C. So that's a squared plus b squared equals c squared. So that's negative 8 squared plus negative 11 squared equals c squared. 64 plus 121 equals c squared. 185 equals c squared. So this is like 5 and 37. Is that right? No.
Yeah, 5 and 37.
Is that right? Yeah. And then they're both prime. So this is just the square root of 185. And again, why are we finding that? Like, because you need all 3 sides to find sine and cosine.
Mm-hmm.
So sine of theta is the opposite over the hypotenuse. It's negative 11 over the square root of 185. The cosine of theta is the adjacent over the hypotenuse. It's negative 8 over the square root of 185. Is that okay? Like, or do you need more explanation on that?
No, that makes sense.
Okay, so question 11 looks like something you know how to do. Do you want any kind of explanation on this?
No, I think I got 11.
Okay. All right, so we're going up to, sorry, I lost, it's on a new page, that's why. 12 looks pretty good. Do you want any explanation on 12?
I think 12 is fine.
Okay. You're using sine, cosine, and tangent there. It's a calculator problem. Okay, number 13. So it says find all of the 6 trigonometric functions given that cosine theta is 5/8 and sine theta is less than 0. All right. So what this is saying is, have you heard this for all students take calculus?
Yeah, I've seen that before.
Okay, here's what this means. It means that in the first quadrant, they're all positive. In the second quadrant, only sine is positive, which means that like if sine is positive, then the others are negative. That's why it's written this way, where the letter tells you which one is positive and the others are negative. So for example, cosine here, do you see how cosine is positive? That means it's either here or here, because in the fourth quadrant, cosine is positive, but all the others, sine, are negative.
Okay.
So now, where is sine negative? Sine is, then that's what's a little bit more confusing. Sine is negative where it's not positive. So sine is positive here and here. Okay, then it's negative here and here. And the overlap is what you want. That is what you are looking for.
Oh, okay.
So the reason I'm doing this is because that bow tie is so important. Like this tells you need to know which quadrant you're in so that you can draw the triangle. And since we're in this fourth quadrant now, we can draw this triangle, and there's theta. And so cosine of theta is 5/8. And because we have to find this third side. So how do you find the third side of this triangle?
So it would be 8 squared minus 5 squared.
That's right. It's 64. It's what, square root of 39?
Mm-hmm.
Yeah. Which again doesn't work out, but it's negative. It's negative because you're going down. So now we can do the 6 trig functions. And I like to write them all out: sine, cosine, tangent this way. And I like to put the reciprocal ones right next to them, because you'll see that they work out pretty nicely when you do it this way. So sine theta is negative square root of 39 over 8. It's opposite over hypotenuse. Cosine theta is 5 over 8. Okay, and then again, like you can flip you can flip these. So like secant theta is 8/5, cosecant theta is minus 8 over square root of 29. And then tangent theta is opposite over adjacent, minus square root 39 over 5. And then this is 5, negative 5 over square root of 39.
Yeah.
So there's actually a lot there for such a short problem. All right, so let me, I just need like 60 seconds here. I got to turn something off, but we'll start with question 14 in just a minute or so. Is that okay?
Yeah, that's fine.
All right, I'll be right back.
Okay.
All right, I'm back here. So question 14, looks like they gave you a picture, which is always nice when they do that. All right, you are a block away from a skyscraper that is 780 feet tall. Your friend is between the skyscraper and yourself. The angle of elevation from your position to the top of the skyscraper is Okay, so 71 degrees. Okay, so how far are you from a friend? Okay, so notice there's really two triangles here. There's this one. Okay. So 780 is a leg, and we really want this one here, x. So the tangent of 71 degrees is opposite over adjacent. Okay, so you probably saw this in class. Are you comfortable solving for x here, or do you want any explanation for that?
I need like a little explanation.
Okay, so you gotta multiply both sides by x because you got to get it out of the denominator. X tangent 71 equals 780, and then you divide by tangent 71 on both sides.
Oh, okay.
So when you're all done, it ends up being 780 over tangent. All right, so do you have a number for that?
I got 268.58.
All right, let me double check here because this is an important one. Yes, we'll call it 269 because it doesn't really matter. Now, the second part of this problem is that you've got another angle this time. This time the angle is, what is it, 42, and this is 780. So you again have to find x. So just like the last problem, it's the tangent of 42 equals 780 over x. Okay, so did you get 866 feet?
Yes, I did.
Okay, so if we go back to that picture, the whole distance is 866, and your friend is 269 away. And then you just subtract the two to find the distance between them. Okay, is that good?
Yes.
All right, so 15 looks like you've got it down.
Can we just go over that one a little bit?
Of course, yeah, of course. So I'll snip it in without your work. Sometimes good to start fresh on these. Find the exact value of everything. So these are 45, 45, 90, and 30, 60, 90. These are special right triangles. So in the case of this 45, 45, 90 triangle, the reference triangle is x, x, and x root 2. And you set your known side equal to your reference side. So you would set 12 equal to x root 2. And then you would divide both sides by the square root of 2. So x is 12 divided by the square root of 2. But here you actually do need to rationalize. I would be shocked if your instructor said, like, you don't worry about that here. And you do that by multiplying the top and bottom by the root. So up top, you get 12 square root 2. And on the bottom, you get square root of 4. Square root of 4 is 2. And then 12 divided by 2 is 6. You might say, okay, well, thanks, Matthew, but I want a. Well, a is x. Do you see that? A and x are the same. So this is 6 root 2. It also happens to be b, because the legs are the same in a 45, 45, 90. So this is also 6 root 2. Is that clear?
Yeah.
Okay. Now on the triangle on the right, okay, it's a 30, 60, 90 triangle. So let me draw that triangle that you're given. And this is 6 root 2. Okay. Now your reference triangle for a 30, 60, 90 is that this is x, this is 2x, and this is x root 3. X is always across from the 30. So you set the known side equal to the reference side. So in your problem, x is really 6 square root of 2. The hypotenuse is double the short leg. Like sometimes it's good to say it in words rather than go off and do that. So 2x is double this. So this is 12 square root 2 here. But then the long leg, this long leg here, it's the short leg times the square root of 3. So this side right here on the left, on the bottom here is 6 square root of 2 times the square root of 3. This is your x times the square root of 3. So with roots, root 2 and root 3, you multiply them together. You get 6 root 6. So when I looked at your problem first, I didn't realize it said no decimals. Whenever you see a 30, 60, 90 or a 45, 45, 90 triangle, you want to use the reference triangles there. And let me send you a couple of links here in the chat to some reference triangle stuff. You might find them helpful for review. So let me just send those by the chat here right over. This first one's a 45, 45, 90. The second one is a 30, 60, 90. And then there's even some practice worksheets on there if you want to look at those as well. That could help with this type of problem.
Perfect. Thank you.
All right, so we're up to question 16, I guess.
Yes.
Is that good? All right.
Yeah.
Okay. All right. So if the cosecant of theta is negative root 2, so one of the things we don't know is we don't know which quadrant we're in. So we have to figure that out. So cosecant is like sine. And if you remember, we did that thing before that, A, S, T, C. So sine is positive in the first quadrant and the second quadrant, which means it's negative in the third and the fourth, which means that cosecant, which is negative, must also be negative in the third or the fourth. Now, they're not giving you much information here, so it actually could be in either quadrant, which I don't like in this question. because it very confusing. So here's theta and here's theta. So the sine of theta is the reciprocal of this. It's 1 over the square root of 2. And we've got a negative somewhere, like it could be on the top or it could be on the bottom. I think maybe the instructor didn't realize this question has multiple solutions, or they just grabbed it from somewhere. But if we go to like this quadrant over here, sine is opposite over hypotenuse. Let's see, that one's going to be negative. And then if we go over here, this one's negative and this one's positive. So in both cases, we need to find the other leg. Here it's positive 1, here it's negative 1. And that's again done through the a squared plus b squared equals c squared. So then to find the tangent of theta is either, depending on which quadrant you're in, it's either -1 over -1, or if it's the one on the right, it's -1 over +1. I apologize if that was confusing. It should be much clearer on the test.
Okay.
And 17 is probably a better example for us to look at anyway. So 17, they actually give you the point. They tell you where it is. And whenever they give you a point, you just graph that point. So square root of 5, -6. This is the square root of 5. This is minus square root of 6. Can you tell me the value of the hypotenuse over here? A squared plus b squared.
So it would just be 1.
It's this squared, right? 5. And then when you square this one, the negative becomes positive.
Oh, okay. So it'd be 11.
Perfect. So now that you have this triangle, that's what's critical. They could ask you for anything here. They could ask you for sine, cosine, tangent, secant, cosecant, cotangent, tangent, whatever. But secant, okay, they want secant. That's 1 over cosine of theta. So you can either find cosine of theta and flip it, or just flip cosine, whatever you want to do here. Cosine of theta, though, is the adjacent over the hypotenuse. Okay, so then you flip this, it becomes 11 over the square root of 5.
Okay, perfect. Yeah, that one makes more sense than the other one.
Great. So our last question here, it says find the cofunction of cosine. So let me snip this in. Cofunction of cosine 55. Okay, so what they're trying to tell you, and there's actually 6 of these. Let me go grab them so you can see. I'm just going to snip these in. Where are they? No. There they are. This one's not as handy. Okay, let me not use this one. So if I give you the cosine of theta, the cofunction is sine of 90 minus theta. So like these numbers have to match. So in your problem, if it's cosine of 55, that means it's sine of 90 minus 55. So that's the sine of 35 degrees. So if you were to put both of these in your calculator, you would get the same result. That's what it's trying to tell you.
Oh, okay.
But there's a bunch of these, like let's say your instructor said, cofunction of secant 32 degrees. Well, this is cosecant of 90 minus 32. And there's 6 of them. The problem is the one I've got here is in terms of radians. But if you replace the pi over 2's with 90s, then you see the 6 co-functions that you get. But you'll notice that they all go together. Like sine goes with cosine goes with sine, secant and cosecant and secant, tangent and cotangent. There's a nice mapping there, so that it's not as, not as much of a struggle to figure out. All right. Is there anything else you would like us to cover in the last few minutes?
I think I have it all good now.
All right. Well, I'll send you the notes here shortly within the next few minutes, and then that screen recording usually put up same day. So if you need to review that before your exam, please do. And if you ever need a question answered before your next lesson, hit me up on my social media for Tutoring by Matthew. I can answer your question there if you've got something quick. Love to help you out with that.
Okay, perfect.
All right. Thank you so much. I'll see you next time.
Thank you.
Have a great night. Bye now.
Bye.